Hello and welcome to the logic of it all. In this video, we will see multiple examples of finite state recognizers and how we can determine which strings, which input streams will be accepted or rejected by a given finite state recognizer. Now, if you remember from the previous video, we looked at this simple finite state machine just as an example for illustrating how these machines work. And we looked at the input stream 0, 1, 0, 1. And very quickly, just to remind you, starting from the initial state with a 0, we go to S1, and then we read a 1. With a 1, we stay there. And then with another 0, from S1, we go to S2. And then while we are at S2, we read a 1, which means we loop back to S2. And since we ended up, after reading the entire input stream, we ended up at an accepting state, it means that the machine accepts this input. On the other hand, if we process the input stream 0, 0, 0, 0, 1, starting again from the initial state with a 0, we go to S1, and then with another 0, with the second 0, we go to S2. And then while we are at S2, we read the next 0, the third 0, which means we go back to S0. And then while we are at S0, we read the last 0 in the input stream, the fourth one. And that takes us back to S1. So we are at S1 and we read the final symbol in our input stream, which is a 1. And that means that we loop back into S1. And because after reading the entire input stream, we ended up at S1, which is not an accepting yes state, it means that the machine rejects this input. So that's how these finite state machines work. Now, what we are going to do in this video through multiple examples and looking at different machines and different inputs for each machine, we want to practice this a little bit more and also see if we are given a machine, can we determine the rule or the pattern of all the strings that are accepted by that machine. In other words, if you remember the terminology from the previous video, given a finite state machine, a finite state acceptor, can we determine the language, which is the set of all strings accepted by that machine? Okay, and here's our first example. Only two states, state 1 and state 2. Our input alphabet is A and B, and you see the transitions in this diagram. So the first question is, does this machine accept or reject the input stream AA, BA? So that's very simple. Starting from the initial state, with an A, we stay at 1. Then with another A, we still stay at 1. Then with the third symbol B, we transition to 2. And then with the last symbol A, we stay at 2. And after finishing the entire input stream, we ended up at 2, which is the accepting state for this machine. And that means that AABA is accepted by this machine. Here's another one, BAA. So let me erase all of this and try again. So BAA, starting from the initial state with a B, we transition to state 2. Then we read the next symbol, which is an A, we stay at 2, and then another A, again, we stay at 2. And you see that we ended up at the accepting state after reading BAA, which means that this input is also accepted by the machine. And here's another one, AAA. So 3 A's is our input. Let's see how that works. So starting from the initial state, which is 1, A, we stay at 1. Second A, we stay at 1. Third A, we stay at 1. So after reading the entire input stream, we ended up at state 1, which is not an accepting state of the machine. And that means that AAA is rejected by this machine. Now, here comes the big question. Okay, now we know how, given a single input stream, how to determine whether it is accepted or rejected by the machine. But the question is, now looking at these three examples and also looking at the machine itself, the state diagram, the state transition diagram, can we determine in general what type of inputs are accepted by this machine, and as a result, what type of inputs are rejected by this machine? Okay, now if you look at this, we always start from 1 because that's the initial state, and we want to end up at 2. So first of all, to get to 2, we need an input symbol B. Now it could be that the input stream starts with a B, or if it starts with one or more A's, that's also fine, because with A's we stay at 1, we stay at state 1, and then as soon as we read a B, we move to state number 2. So to get to state 2, which is what we want to end up at, our input must contain at least one B, right? So, and it could be that it starts with no A's, immediately starts with a B, or it could be that it starts with one or more A's and then a B. In both cases, when we read the B, we move to state number 2. And if you look at the diagram, if you get to state 2, then it doesn't matter what input you read after that, because if you read an A, you stay here. If you read a B, you stay here as well. So what follows is not going to take you back to 1. So if you get to state 2, no matter what you read after that, you will always stay at 2, which means that the input will be accepted. So one more time, how do we get to 2? If we read at least one B, we get to 2. And then after that, we always are going to stay at 2. So in general, we can wrap this up and say every input stream that contains at least one B will be accepted, because with that one B you get to 2, and then whether there are more B's or A's after that, you're still going to stay at 2, which means that at the end the input will be accepted. So the language accepted by this machine is the language of all strings that have at least one occurrence of the letter B in them. In other words, the inputs that are not accepted or rejected by this machine are the inputs that consist of A's only. So either A or AA or AAA and so on. And we see one example of that here. Now, here's another machine. We are going to do a similar thing here. Now, the reason that we are doing this over and over is, first of all, it's important to be able to, at least for simple machines, be able to look at the machine and analyze it and find the language accepted by that machine. It is also going to be helpful for the next step, which is now we are, in the next video, we are going to talk about this, and that is you are given a description of the language that should be accepted by a machine, and then you want to design the machine. So it's the other direction. And understanding this step that we are doing now is going to be crucial in being able to design the machines properly. So back to the example, we have 3 states, 0, 1, and 2. We have the transitions. Our input alphabet is A and B, and our accepting state is 1. So if our input is A, B, B, A, what happens? We read A, we transition to state number 2, then we read the B. With this loop here, we stay at 2, and then we read another B, again using the same loop, we stay there, and finally we read A, and we stay there as well. By the way, when we have 2 symbols on the same edge, like A comma B, it means that this is like a shorthand for having 2 edges with one with A and one with B. So the same edge works when we read A or B. Okay, so going back to this example, we ended up at state 2 after finishing the entire input stream, and 2 is not an accepting state, which means that this will be rejected. The next example, BABA. So again, starting from the initial state, reading the first symbol, which is a B, we take this edge this time and we go to 1, which is an accepting state, but we shouldn't rush this because we need to read the entire input before making a decision. So the next symbol is an A. So with this edge, we stay at 1. Then we read a B, again using the same edge, we stay at 1. And reading the last symbol, which is an A, again we stay at 1. And we see that after reading the entire input stream, we ended up at 1, which is an accepting state. And as a result, BABA is accepted by this machine. The next example is BBA, the next input stream. So following a similar approach, starting from the initial state, we read the first letter, which is B, we transition to 1, then we read the next symbol, another B, we stay at 1, and we read the last symbol, which is an A, and using the same edge, we stay at 1. So we ended up at an accepting state, which means that this is also accepted. So now we again ask the big question. Now, for these three examples, we realize that ABBA is rejected, BABA is accepted, and BBA is also accepted. So looking at these three and also looking at the finite state machine, the diagram, can you determine the set of every string that is accepted by this machine? In other words, the language accepted by this machine. What type of strings are accepted? Okay, now if you analyze this, you see that we always start from the initial state, and then if our first symbol in the input stream is an A, we transition to 2, and then whatever comes after that, whether A or B or any combination of that, we can't get out of 2, right? So 2 is like a black hole. When you get there, whatever comes after, you can't get out of 2, which means that you never end up at the accepting state. So if your input starts with an A, that input is doomed to be rejected, because with that A, you move to 2, and then there is no way out of 2. And 2 is not an accepting state. On the other hand, if your input starts with a B, if the first symbol in your input stream is a B, again, starting from the initial state, which is 0, you read the first letter. If that's a B, you move to 1, and then you're in a similar situation, because no matter what comes after that first B, A or B, whatever letter follows that, and as many, it could be that there's one A or a B or any combination of that, whatever comes after that initial B, you will never leave the state number 1, which means that no matter what follows, this input stream will be accepted. So to summarize, if your input starts with an A, you end up at 2, and then whatever follows is not going to help you. That input is going to be rejected. But if the input starts with a B, you go to 1, and then whatever follows that, you never leave 1, and that means that it will be rejected. So the machine accepts every string that starts with the symbol B and rejects every string that starts with the letter A. Now, here's our next example. This is a finite state recognizer with two states, 0 and 1. The input alphabet is A and B. Again, similarly, we want to start with concrete, input streams and then generalize. So A, B, B. So with an A, you go to state number 1, and we may think that, okay, now everything is fine, we are going to accept. But then we read the next symbol, which is a B, and then this edge takes us back to state 0. So there is no guarantee that if you get to the accepting state, you're going to stay there because of this edge here, right? So the behavior of this machine is different from the previous one. And then you read the last symbol, which is another B, and with that you stay at 0. So since we ended up at a state that is not an accepting state, this input will be rejected. Now here's the next input stream, this time BAAB. So again, starting from the initial state, the first B, we stay at 0, then we read an A, we transition to 1, then we read another A, we stay at 1. It seems like we are going to accept this, but then we read the final symbol, which is a B, which takes us back to state number 0, and that means that this input is also rejected by the machine. And the third one is BABA. Again, following a similar procedure, starting from the initial state, with a B, we stay at 0. With the next symbol, which is an A, we go to 1. Then we have a B, which takes us back to 0. And then we read the final symbol, which is an A. Remember that we are at 0 at the moment. With that A, we will end up at state number 1, which is an accepting state, and that means that this input will be accepted by this machine. So again, we want to know now, after seeing three examples, can we in general determine what type of strings will be accepted by this machine and what type of strings will be rejected. Now, if you think about it, you need an A to get to the accepting state, starting from the initial one. If the only letters that you see is B after B after B, you're going to stay at 0 and you never reach to the accepting state. So to get there, you need an A. But then when you get there, if you see more A's, that's fine. But then a B takes you back to state number 0, which is not accepting. And then you need another A to get you to state number 1. And if you think about it, the requirement here is only focused on the final symbol in the input stream. If the final symbol is an A, you end up at state number 1 and you accept. If the final symbol is a B, and then you are going to end up at state number 0 and the machine rejects your input. So we can say that this machine accepts all strings that end with the symbol A. And everything that ends with the symbol B will be rejected. In the next example, we have 4 states named 1, 2, 3, and 4. Our input alphabet is A and B, and state number 4 is the accepting state. And again, we want to go through a similar process. So our first example of an input is B, B, A, B, A. So reading the symbols one at a time, starting from the initial state, the first B stays at 1, then we read another B, stay at 1 again, then we read an A, which takes me to state number 2, so now I'm here, then I read another B, I stay at 2, and then I read an A, that takes me to state number 3. So I made good progress to reaching the accepting state, but I ended up at 3. I didn't exactly get to the accepting state. So since I ended up at the state number 3, which is not an accepting state, this input will be rejected by the machine. The next example, A, B, A, B, A. So let's start over. So starting from the initial state, the first symbol from the input is A, which takes me to state number 2. Then I read a B. With a B, I stay where I am. Then another A, which takes me from state 2 to state 3. Then another A, which takes me to state number 4. And then a B. And state number 4, if you read a B, you transition to 4 itself. And finally, an A, which again, you transition from 4 to itself. So after reading the entire input, we ended up at 4, which is an accepting state, which means that the machine accepts this input. And here's another example. Same machine, the input is BA, 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 BB. And let me do this one quickly. So with the first B, we stay at 1. Then with an A, we go to 2. Then with the next symbol, which is a B, we stay at 2. And then we read an A, that takes us to 3. And then we read a B, we stay at 3. And then an A, we move to 4. And then 2 B's in a row. So we use this edge twice. And we end up at 4, which is an accepting state. So the machine accepts this input. So now, again, the same general question. Can we specify all the strings that are accepted by this machine? And again, looking at these 3 examples and also the diagram, you should be able to figure this out. So you see that if you look at the machine, first of all, if we somehow get to state number 4, then it doesn't matter what follows, because whatever follows, we are going to stay there, whether it's an A or B or any combination of A's and B's. We are going to end up at 4. So the important thing is getting to state number 4, then we are going to stay there no matter what follows. Now the question is, how do we get from the initial state to state number 4? And you see that for each one of these states, 1, 2, 3, while we're there, if we read the letter B, we are going to stay there. But if we read the letter A, we are going to progress to the next one. So to get from 1 to 2, we need 1A. and then to get from 2 to 3, we get another A. We need another A, and to get from 3 to 4, we need another A. And it doesn't matter if there are occurrences of the letter B in between these A's, because after the first A, if we read some B's, we are going to stay at 2, one more, 1, 2, 3, as many times until we read the next A and move to 3 and so on. So to summarize, if our input stream consists or contains 3 occurrences of the letter A, that is good enough to reach to state number 4. And then if we get there to state number 4, then whatever follows, we are never going to leave state number 4. So this machine accepts every string that contains at least 3 A's. Whether they're consecutive or not, it doesn't matter. And you can check that with the examples that we have here. So the first one that has only 2 A's, and that's why it's rejected. The second one has 1, 2, 3, 4 A's, that's why it's accepted. And the third one has exactly 3 A's, and that one is also accepted. So at least 3 A's. And here's another example. And now this one is kind of similar, because you see instead of A's with zeros, you transition from state number 1 to 2, and then with a 0 you transition from 2 to 3, and then with another 0 you transition to 4, and then when you get to 4, which is an accepting state, no matter what follows, you're good, you're going to stay at 4. So in that sense, you might think that, okay, having 3 zeros is going to be good enough. The main difference is, if you read the first 0, for example, in the previous example, in the previous machine, after reading the first symbol, then with a B, or in this case with a 1, you would have stayed at the same state. But in this machine, if you read the first 0, and then the next symbol that you read is a 1, that takes you back and you need to start over. Or if you read 2 zeros, and those 2 zeros take you from 1 to 2, and then from 2 to 3, so you are here. And then you don't see the next 0 immediately, but you read a 1 after that. Again, that takes you back to the beginning. So another way of saying this is, in this example, in this machine, you need 3 zeros to get to the final, to the accepting state, but these 3 zeros should not be interrupted by 1s, because if they are, then that 1 takes you back and you need to start over. So if you look at this first example, 0, 0, with the first 2 zeros, from 1 we get to 2, and then from 2 to 3, but then that 1 here takes us back to state number 1, and then a 0 takes us to state number 2, but then that 1 again takes us back to state number 1. So this will be rejected. You can follow the edges for this one as well. So if you are at 1, the first symbol you read is a 1, you stay there. Another 1, you stay at 1. Then you have a 0, you move to state number 2, but then the 1 takes you back to state number 1, so this one will be rejected as well. Now this one is different, because we have 3 zeros in a row. So if you look at this, with the first symbol 1, we stay at the initial state. Then we have 3 zeros back to back. So with the first 0, we go to 2, then from 2 to 3, and then from 3 to 4. And when we get to 4, it doesn't matter what follows. In this case, there's only a 1, but it could be any combination of zeros and ones. We are going to stay at 4. So this input will be accepted. And as I explained, what is needed for an input stream to be accepted is having 3 zeros in a row, 3 consecutive zeros.